Okay, so let's look a little bit more at properties of logarithms and make it a little bit more hardcore, I guess. So say we want to just continue expanding, and we want to expand log of 5x squared over 2y to the fifth. I'm going to say my 5 and my x squared are being multiplied, so I'm going to write log of 5 plus log of x squared. And my 2 and my y to the fifth are being multiplied, but the product of them is being divided. So I have to distribute that negative all the way through. So I'm just going to write minus log of 2 minus log of y to the fifth. So hopefully we can kind of see right here, if I have stuff in the numerator, it's being multiplied. That means it's being added. So when you're expanding, if you have stuff in the top, you add the logs. Stuff in the bottom, it's still being multiplied. My 2 and my y to the fifth are being multiplied, but the product of them is being divided, meaning I have to subtract and I have to distribute that negative. So if you have stuff in the bottom, you just subtract the logs. And that's really it. It's all about placement with logs. So hopefully here you see that the exponents can come down. So I would have log of 5 plus 2 log of x minus log of 2 minus 5 log of y. And that is expanded. Okay, so let's look at the next one. Log base 2 of 3 square root of x to the 6 over 7y to the 4 cube root of z to the fifth. So I'll go ahead and expand this. So stuff on the top is being added. So log base 2 of 3 plus, and we're just bringing down these exponents, so I'm just going to bring down the exponent while I'm expanding it. So can I simplify square root of x to the 6? And I can. If I simplify square root of x to the 6, x to the 6 is just going to be x cubed. So I'm going to write 3 log base 2 of x. Okay, so stuff on the bottom is being subtracted. So minus log base 2 of 7 minus, again, my exponent is just going to come down, so 4 log base 2 of y minus, and can I simplify cube root of z to the fifth? And I kind of can. I'd have to do a little bit of work. I'd have to break down my z to maybe z cubed times z squared. Or I can just rewrite it as an exponent. I can say, instead of cube root of z to the fifth, I know that if I'm simplifying it, I'm dividing by that root. That's how you got x square root of x to the 6 to be x cubed. You just divide it by 2. Since logs are all about exponents, I'm just going to write it as an exponent, 5 divided by 3. I'm going to get z to the 5/3. If I do that, then I'm going to bring down that 5/3 log base 2 of z. And that's it. We're done in one step. We have expanded it. Okay, let's try the last one. It looks a little tricky. There's a few ways I can start this. So I have log of 6x to the fifth square root of y over 11x plus 3 whole thing, well, that to the second power, whole thing to the fifth power. Okay, I can start a few ways. I do have this exponent on the outside, so I could distribute that exponent all the way through and raise my 6 to the fifth power, my x to the fifth to the fifth power, my square root of y to the fifth power, and so on. That is a perfectly legit way to do it. Or, since it's a log, I can bring down that fifth at the very beginning and write 5. So I'm going to write this as 5 log and keep everything else the same. I guess I don't really need that parentheses anymore, but, well, I already wrote it, so tough luck. 6x to the fifth square root of y, 11x plus 3 squared, and again, that useless parentheses now. And now I can go ahead and expand it. This 5 that's in front of this log, that 5 in front of that log, is going to have to stay in front of the whole thing. So I'm going to write a 5 and I'm going to write a parentheses to show that that 5 is in front of the whole thing and belongs to every single log that's going to come out of this. So let's see, my 6 is in the top, so that's going to get added. My x to the 5th is in the top, so that's going to get added. My 5 is going to come down, so 5 log of x. My square root of y is in the top. That's going to get added, and that is not actually a square root of y. That is a y to the 1 over 2. I can write it as an exponent. So I'm just dividing by 2. The exponent of the y was a 1, so I'm just writing it as 1 over 2. So 1/2 log of y. Okay, my 11's in the bottom, so I'm going to subtract it. Minus log of 11. And my x plus 3 whole thing squared is in the bottom, so I'm going to subtract it. So minus 2 log of x plus 3. And I'm going to close off the bracket. So this shows that the 5 could be distributed. It is in front of every single one of the logs. There's 5 on the outside. And everything else is now expanded. One thing to be careful of is this last thing, that 2 log of x plus 3. A lot of people wanted to try to distribute the log. The log is something that's happening to it. It's not a number, it's not a constant. It is saying, again, our base here is 10. It is saying 10 raised to some number gives me x plus 3 whole thing squared. So I can't distribute that log. It just stays log of x plus 3. Okay, let's see if we can go backwards. So we want to write these as a single log. So we have 3 log of x minus 8 log of y minus 2 log of 3 plus 7 log of z. So going backwards is, well, just going backwards. If I am adding the logs, that means it ends up on top. If I am subtracting the logs, that means it ends up on bottom, or in the denominator. And like before, when we brought down the exponents, these coefficients go and become exponents. So let's see if we can do this. If I write as a single log, then I'm going to write a single log. Single log means 1. And I want it to kind of look like these up here, so I'm going to write log and a fraction bar next to it. So anything where I'm adding logs, or I have positive logs, adding logs means positive. I'll write that here also, so that way we can see it. So positive or add logs means it goes on top. So my 3 log x is positive. So x to the 3 goes on top. My 7 log z is positive. So my z to 7 goes on top. My minus 8 log y is subtracting. So my y to the 8 goes on bottom, and my minus 2 log 3 is subtracting, so my 3 squared goes on bottom. This is basically it. I would want you to simplify a little bit, really make that 3 squared a 9, and that's about all you can do. So log x cubed z to 7 over 9y to the 8, and done. Let's try the next one. Say I got 4 natural log of x minus 9. Ah, crap. These are all supposed to be natural log. We're going to turn these on to natural log. I guess I stopped writing natural log for whatever reason. Minus 9 natural log of y plus 3 minus 3 natural log of 2. Okay, we haven't seen natural log yet. But natural log is another log that you see often, like on your calculator and computers. You really only ever see 2 logs. You really only ever see log, which we discussed earlier, was log base 10, and you see natural log. Natural log is log base e. E is a constant. It's kind of like pi, and it's used a lot in economics and bio, and it comes from an exponential equation, actually. It's 2.1718, something like that. But it's a constant, and we can treat the natural log the exact same way we treat a log, since it is a log. It's just log base e. Okay, so if I'm going to write this as a single log, then I'm going to write a single log. I'm going to write natural log, since that's what I'm working with. And let's see, stuff that's positive or being added goes on top. So my 4 natural log of x is positive. That means I have x to the 4 on top. And things that are being subtracted are on bottom. So my minus natural log of y plus 3, my minus 9 natural log of y plus 3. So I'm going to have y plus 3 to the 9. And my minus 3 natural log of 2. So I'm going to have 2 cubed on the bottom, which is 8. That's it. Okay, let's try the last one. I got 3 times log base 2 of x plus 7 log base 2 of y minus 2 minus 3 log base 2 of 5. Can do this 2 ways. I can distribute my 3 all the way through. So if I do that, I should get, it's going to just be multiplied times the number on the outside of the logarithm, kind of like when you were multiplying numbers times radicals. Just got multiplied times the numbers on the outside of the radicals. So 3 log base 2 of x plus 21 log base 2 of y minus 2 minus 9 log base 2 of 5. Now I can write this as a single log. So I'm going to write a log base 2, and I'm going to write didn't mean to write an equal sign, just a fraction bar. And on top is going to be the positives or stuff being added. So x is 3 and y minus 2 to the 21. On bottom, I'm going to have stuff being subtracted, so the 5 to the 9. I do not expect you to know what 5 to the 9 is. That's ridiculous. So just keep it like that. Okay. Other way I could have done this is look on the inside, and I could have simplified that first. Could have kept my 3 on the outside and simplified my inside to be x on top, y minus 2 to the 7, and 5 cubed. Then I know again this is in front of the log, so it would actually go as an exponent to everything. So I really would just have log of x, y minus 2 to the 7 over 5 cubed, whole thing to the third power. I could leave it like that. I could distribute my 3 if I wanted to the exponents on the inside. I could leave it like that and make my 5 cubed a 125. Really, all of those answers are quite fine. Okay, hopefully that made sense.